Hi! In this episode, we will see in detail about the types of curves. And the elements of curves. And the derivation of some important formulas. Just in 10 minutes' time. Welcome to Civil Guru. These videos made in different languages, like English, Hindi, Tamil, and also in Arabic now. Please choose your desired language from our playlist. If you like this video, please like and subscribe now, and share it with your friends. Thank you. From this episode onwards, we will discuss about the curves. Let us see the major types of curves. The first one is vertical curves. The vertical curves are introduced to provide smooth traffic movement of the vehicles where two different gradients of roads are meeting. And the second one is horizontal curves. The horizontal curves are introduced to provide a smooth transition while a change in direction of moving vehicles when two different road alignments are meeting at one point. Now, let us see the types of horizontal curves. 1. Simple curve. An arc is imposed as simple curve while two different straight lines are meeting at one point. 2. Compound curve. Compound curves are the combination of two simple curves with different radius combined together to curve in the same direction. 3. Reverse curves. Reverse curves are the combination of two simple curves in opposite directions combined together to curve in the road alignment. Transition curve. Transition curves are a spiral curve with varying radius. It is introduced between a straight line and a simple curve. This type of curve is used to connect a straight line and a simple curve, where the radius of the simple curve is very less and super elevations are required to be imposed. The super elevation. While turning a vehicle, it is exposed to two kinds of forces. 1. The gravity, which attracts the vehicle towards the ground. 2. The centripetal force, which is an external force required to keep the vehicle on a curved path at any velocity. The centripetal force would be large for a smaller radius than a larger radius. To solve this issue, while designing the horizontal curves, the roads are slightly tilted in crossword direction at a slight tilting angle. Thus, provides ease and comfort to the drivers while turning the vehicle. This phenomenon is defined as super elevation. Now, we will see about the elements of the simple curve. As we all are aware that the curves are imposed between two straight lines from different directions for the change of road direction. The point where these two straight lines are meeting is the point of intersection, and it is denoted as IP, or sometimes it is denoted as PO. The angle between these two straight lines is the deflection angle, and it is denoted in theta. The point from where the curve starts is the tangent point 1, and known as the point of curve, and it is denoted as T1. And the point where the curve ends and continues as the straight line is the tangent point 2, also known as the point of tangent, and it is denoted as T2. A straight line that connects these two tangent points is the chord, also known as the chord length. Now, the center of this chord is the midpoint, or midpoint of the chord. From now, please listen carefully, because these are all very important points. The distance from the midpoint of curve to the intersection point is the apex, also known as the apex distance. And the distance from midpoint of curve to midpoint of chord is the versine. Every highway engineer shall know about this, and always shall remember these 2 points. Because these 2 points are repeatedly asked in public service exams. And also it plays very important role while designing of the curves. The angle from the tangent point to the midpoint of curve is known as the degree of curve. Now, we must remember few basic things. The radius of curve is always perpendicular to tangent line. So, the included angle at center of curve between these two tangent points is always equals to the deflection angle at intersection point. Now, for easy calculation purpose, let us draw an imaginary straight line, connecting the points from the point of intersection, and then the midpoint, and to the center of circle, which is the origin point of radius. This imaginary line is bisecting the chord, which means it is perpendicular to the chord length C. With the help of this line, it forms as a right-angled triangle. And the angle between the starting of the radius to this imaginary line is theta divided by 2. And the distance from midpoint to tangent point is half of the chord, which is c divided by 2. Now, let us see in detail about the elements of a simple curve and derive some important formulas by using simple trigonometry. First, the curve length L. Already we have discussed about the derivation of pi value and also how to calculate the arc length in our previous episode. As we all knew that the perimeter of any full circle is 2 pi r, which covers 360 degrees. For semicircle, it is pi r, which covers 180 degrees. Now, to calculate the arc length of a segment in a semicircle is proportionate to the value of semicircle, which is pi r divided by 180 degrees into the theta. The next is the tangent length TL. Considering this right-angled triangle, the tan theta by 2 is equal to the opposite side divided by the adjacent side. Here, the opposite side is the tangent length, and the adjacent side is the radius. Then the tangent length equals to the radius into tan theta divided by 2. Now, let us see about the apex distance, also known as the external distance E. Using the same right-angled triangle, the cos theta by 2 equals to the adjacent side by hypotenuse. Here, the adjacent side is the radius r, and the hypotenuse is the total length from O to C. Now, the hypotenuse OC equals to radius r divided by cos theta by 2, which is also known as r secant theta by 2. Now, the apex distance equals to r divided by cos theta by 2 minus radius, or r into secant theta by 2 minus radius. While designing the curve, most of the cases, we may know the apex distance from the field. Then, with the help of that, we can calculate the radius, which is hypotenuse OC minus apex distance, which gives the radius of the curve. And the next one is the length of the long chord L. Considering this right-angled triangle, as we all know, the sin theta by 2 is the opposite side by the hypotenuse. Here, the opposite side is half of the long chord C by 2. And the hypotenuse is the radius r. Now, the half of the chord length C by 2 is equal to r into sin theta by 2. And now, the length of the long chord C equals to 2r sin theta by 2. Finally, let us see about the midordinate M, or the versine. By using the same right-angled triangle, the cos theta by 2 is equals to the adjacent side by hypotenuse. Here, the adjacent side is CD, and the hypotenuse is the radius r. Now, the length of CD equals to r into cos theta by 2. And the midordinate M equals to r minus r cos theta by 2. In next episode, we will see about the designing of simple curve in detail. If you like these videos, please subscribe now and share with your friends. And also don't forget to press the bell button. Thank you.